There you go. Technical difficulties. All right, this is 9.4, 9.5, something like that. I think it's 9.4. Partial fraction decomposition. When something decomposes, it falls apart, it breaks up into pieces. So that's what the idea of this is going to be about, breaking something up into pieces. So let's take a look at let's start with the end result and then work backwards to see where it comes from. Let's say we had 3x minus 2 plus 2 over x plus 3. Like, let's say we started there. If we wanted to get a common for one fraction, we could multiply this one by the other denominator, multiply this by x plus 3 over x plus 3. And we could multiply the first one by the first denominator. So multiply this by x minus 2 over x minus 2. And I put parentheses on the bottom so it's clear that what we got going on. So we'll end up with one denominator, x plus 3 times x minus 2. And I've got 3 times x plus 3 plus 2 times x minus 2. If I multiply that top out, I get 3x plus 9 and then 2x minus 4. And then I have 5x plus 5 after I combine the terms on the numerator over x plus 3, x minus 2. Here we combined or made a composition of fractions by finding a common denominator. It's been a while, but we've done this before. That's old stuff. That's not the new stuff. How do we go the other direction? Or uncombine the fractions. It's a shitty green pen. So can I start with 5x plus 5? Hey, Billy. And with x plus 3 with the 2 on top. And x minus 2 and 3 on top. How do we go that direction? So the first thing we're going to talk about is for each term in the denominator, or not for each term, for each factor in the denominator. What?
Everything is blurry. I cannot see. Wait. It's getting better. It's getting better.
It might be your own eyes.
No, that's not my eyes.
It's your connection, dog.
Yeah.
Jimmy,
You can go a little bit up.
you're not here. What the fuck, Jimmy?
You can go a little bit up so I can take a picture because it was blurry and I was waiting until it got better.
I'm tired of driving to Tulare every day. Every class.
Hurting my feelings.
Oh well.
I would go to Tulare, but it's too expensive.
Someone wants an ass. Oh well. Not like I'm sorry for your loss, Mr. Jones. I know my company is so pleasant that they love having me in class. It was just like, you can go fuck yourself. I'm not coming in.
No, I'm just messing with you, man.
It's too late. You're already getting that.
All right.
Now, all right. So for each factor in the denominator of the form ax plus b, there will be a term of the form a over ax plus b, where big A is a constant. So that's kind of like an A1 and that's kind of like an A2 or A and B. I'll probably use A and B. These red pins can be used very little because it's shitty. So let's do that with this problem. I know the result should be a 2 and a 3, but let's show how we get there. So I've got 5x plus 5 over x plus 3 times x minus 2. And I should have something of the form a over x plus 3 plus b over x minus 2 when I'm done. Here we get a common denominator. I'll multiply the x plus 3 like we did above times x minus 2 over x minus 2. And I'll multiply the b times x plus 3 over x plus 3. And we know we should end up with, should get a equals 2 and b equals 3. That's from the first page. I just didn't want to leave it up there. So that's what we should do when we're done. So where we go from here is. Bottom's equal, so top's equal. So I have 5x plus 5 equals a times x minus 2 plus b times x minus 3. And I'll distribute that. Ax minus 2a plus bx minus 3b. And then I'm going to group the x's together. I have a plus b x that should be a plus 3 right there. That's a plus 3b. Three b minus 2a. I think this is hella neat. So just as the bottom equal force the top to be equal. If these things are supposed to be equal. Then the coefficients must be equal. That must equal that. And that must equal that. A plus b equals 5. I'm gonna put this in the other order, negative 2a plus 3b equals 5. So I could multiply this one by 2, I would get 2a plus 2b equals 10, if I multiply it by 2. And if I just put the negative 2a plus 3b underneath it, I can add them. And I get 5b equals 15, or b equals 3. And then I'll take that and plug it back into one of the original equations. If I do that, I've got a plus 3 equals 5, so a equals 2. Which is what I wanted above. And then I take these, take a and b. And plug into the fractions above. So I've got 5x plus 5 over x plus 3, x minus 2 equals a, which is 2 over x plus 3 over x minus 2. I don't know about you, but I think that's pretty fucking cool.
This A should have to be 2, can it be 3?
Say what?
Like, you know how it's A or B, or A equals 2 and B equals 3, can A 3 and B equal 2?
If you put the letters in different order. If we ended up with 3 over x plus 3 and 2 over x minus 2. When you put them back together, it wouldn't equal the left side.
You know what I'm saying? There's like switch spots, basically. Like it would be A over x minus 2 or and B over.
Yeah,
You know?
yeah, the order I picked here was, I could have done the other way.
Yeah.
If I had done a over x minus 2, I would have had a equals 3. That's what you're asking, right?
Yeah.
Yeah. So the order I picked these didn't really matter. So I'm gonna show you.
Wait. Sorry, my connection is going bad right now. Thank you. I'm done.
Are you sure?
Yeah.
Okay. So I want to show like a faster approach here. I'm going to come back up here to the 5x plus 5 equals a times x minus 2 plus b times x minus 3. So let's backtrack to when we compared the tops. Because we had to do a system of equations to solve that, and there was only 2. But I bet you can imagine that gets tedious as fuck. Especially if there's a lot of them. So we had 5x plus 5 equals a times x minus 2 plus b times x plus 3. Shortcut. Doesn't always work, but it works most of the time. Works when there is no factor to a greater exponent. Which you'll see in a second. The shortcut is step 1. These were the 2 denominators. Find what makes those things 0. I keep using that red pen even though it's shitty. That red should be blurry, Josue.
What happened?
That red ink should look blurry to you because it's not a good pen.
Okay, no, I see it fine right now, but sometimes it gets blurry and come back to normal.
Okay. So x minus 2 equals 0 and x plus 3 equals 0. I get x equals 2 and x equals -3. I'm only writing out the x minus 2 equals 0 just to point out where I'm coming from. Most people can look at it and go, plugging in 2 will make that 0. Plug these in one at a time. So I had 5x plus 5 equals a times x minus 2 plus b times x plus 3. I'm going to write this twice because I'm going to do it twice, depending on what number I'm using. If x equals 2, this is 5 times 2 plus 5 equals a times 2 minus 2 plus b times 2 plus 3. 15 equals 0a plus 5b. So 15 equals 5b. B equals 3. And I didn't need a system of equations. I just took advantage of where the denominators were going to be 0. Does that make sense? If we do the x minus x equals -3, it's going to cancel out the other one. 5 times -3 plus 5 equals a times -3 minus 2 plus b times -3 plus 3. I have -15 plus 10 is -10 equals -5a plus 0b. So I divide by -5 and I get 2 equals a. You guys ready for some more? Let's go back further.
No. Let me take a picture. I'm sorry. I'm behind. Sorry, I got a
That's why I
compliment.
ask. I said, is everyone ready? That's where you say no.
Yeah. Yeah, I'm ready.
You know, we tell them fucking moving it.
Sorry, I'm behind. I'm taking picture and getting in rush.
But just tell me. Just tell me, no, I'm not ready.
Yeah, it took me some time to get into the mute.
All right, we're gonna go back another second. We're gonna go back to before we tore the fraction apart. Let's go back all the way before we even fucking put the thing together. X minus 2. Or plus b. What if we do the x equals 2 and x equals -3 here? Well, it's gonna make some denominators 0. Which is bad juju. Don't do that. I guess you still have to get the common denominator. There's no dodge in that. You still have to at least put them together. So you can only go back so far. Or start the easy, or start the shortcut or at a certain point. After you have a common denominator. Or just clear the fractions. So I had 5x plus 5 over x plus 3, x minus 2 equals a over x plus 3 plus b over x minus 2. And what we're going to do is we're going to multiply everything by the big denominator, x plus 3 over x minus 2. That way you're not stopping to think about how clearing fractions work. This just saves you some time, or getting a common denominator gets tedious. This saves some time. Just multiply through by the denominator that you're trying to tear apart. On the left side, the denominator just wipes out with what we multiply through by. Here we got x plus 3, x minus 2, and x plus 3, x minus 2. We distribute it to both of them. For this one, the x plus 3's cancel. And I'm left with a times x minus 2. And for this one, the x minus 2's cancel. And I'm left with b times x plus 3. So you might find that easier than getting the common denominator. The result is the same. When we got a common denominator and compared the tops, we had that. And we still have that. So multiplying through might make it a little bit easier for you. So let's try another one. Are you ready, Josue?
Give me a minute.
Okay.
Yeah, I'm done.
Okay. In this one, we're gonna have 11x plus 2 over 2x squared plus x minus 1. And we want to decompose this. Well, first we need to factor the bottom if we can. If you do, when you factor it, you should get 2x minus 1 and x plus 1. So Luis, which letter do you want to put with A and which letter do you want to put with B?
Being similar.
You're a rebel. All right, so clear fractions. Multiply by 2x minus 1 and x plus 1. If you do, this turns into 11x plus 2 equals b times x plus 1 plus a times 2x minus 1. Shortcut will work here. So this one, the denominator would be x equals 1/2. And this, the denominator would be x equals -1. So these are our shortcuts. So if x equals 1/2, this becomes 11 times 1/2 plus 2 equals b times 1/2 plus 1. The a will go to 0. So I have 11 over 2 plus, I'm gonna get a common denominator right here, this will be 4 over 2 equals 1 and 1/2 is 3/2. So b times 3 over 2. So I've got 15 over 2 equals 3/2 b. Multiply both sides by the reciprocal. And I get. Here the 2's cancel, and I have 15 divided by 3 is 5. And we'll do the same thing with x equals -1. I have 11 times -1 plus 2 equals b times 0 plus a times 2 times -1 minus 1. -9 equals -3a. Divide by -3. And I get a equals 3. That's not your answer. You don't just put what a and b are. When you're done, go back up and reassemble them. Plug them into what you broke them down into earlier. We said b was the 1 over the 2x minus 1. So I got a 5 there. And this one's a 3 over x plus 1. How can I check this? Well, I don't want to plug them in, it's gonna cause a denominator to break. I could just get a common denominator and then add the numerators and see if I get 11x plus 2 on top. Right? Check by combining the fractions. And comparing tops and bottoms. Hey Jimmy, you remember Hannah saying she's always here? I don't see no Hannah. I don't see no Hannah online either.
What's up?
Nothing, I'm just chit-chatting.
Oh, sorry, I didn't hear what you said.
I said just the other day, Hannah said she's always here.
Oh,
And
oh
she's
yeah,
not here.
I do
She's not on
recall.
the list.
Yeah,
She's
I
not
do
on the
recall.
participation list.
Yeah, I did recall her saying that last week or last class. Yeah, you can call her out on that next time.
Right?
And you got it on recording.
Eric, yeah, right? She'll see it in the video.
Yeah.
Hannah, what the fuck? Eric told me he wasn't going to be here. I knew Eric wasn't coming. Jimmy made it all the way till the end of the fucking semester, and then like Thanksgiving came, he's like, fuck it, I'm done with you, Jones.
There's been so much construction on Mooney and going to Tulare. I'm tired of having to
No
drive through it.
shit.
I'm tired of
I
it.
hear you.
Yeah.
Yeah. All of them, like not just even in Visalia, but like down here, Bardsley and Mooney's even got shit going on. And
So
I know
I
Mooney, you're oh, what's that fucking chicken place?
don't know.
It's near Caldwell.
Angry chicks.
Dave's Angry Chicken and the other one, yeah, that area has last weekend it had shit going on. I don't know if they cleaned it up yet.
Literally all the way from Dinuba to Visalia to Tulare is construction just all the way straight through. So I'm kind of just tired of driving through all that.
That's why you hop on the freeway and just fucking got it.
No, that's all. Yeah, that too. But I mean, it's
I
from Dinuba from Dinuba to Visalia, you have to go through Road 80. You know, you can't go any other way.
But I have one question, Jimmy. I have just one question.
Mm.
To attribute to this way. How are you sharpening your pencils?
I don't have no sharpeners.
I told you stockpile them up, sharpen up a bunch, and then you don't have to ask them all the time. You'd done that last time I'd seen you and was fucking with you. You'd have a whole bag of sharpened like wooden stakes. So you go on your vampire hunting mission.
I just have a bunch of them now.
Let's kick it up a notch. We were doing AX plus B on bottom. But what if AX plus B is to an exponent? I'm going to say like to N. So there's repeated factors on bottom. The way you do this is you do the first one regularly, A over AX plus B. And then you do another one with AX plus B squared plus C over, and depending how big N gets, is how far you go with this. Now you might only go up to 2. I'd be surprised if I put a cube in anything, but the homework can be a dick like that. Am I right?
Yeah, the homework do sometimes very hard problems. Well, you're not moving. Oh.
What?
You were like a statue. I thought the
Oh, that'd be fun. I should fuck with those way like that.
Yeah,
Good
I
to
thought
learn. Yeah, I was, but
the
people were
screen
still
freeze.
writing, so I was just sitting there, just chilling. Let's do an example. I think it's easier to see when we're doing shit. So I can break this up into three fractions. I have an x term, so that's gotta go be one of them. And then I have my first x minus one. And I have another x minus one, so we'll do x minus one squared. So we will multiply by x times x minus one. I think it's a little easier to see the x minus one right now instead of squaring it, showing that. If I do, the left side just has the denominator wiped out. Here I have a times x minus one times x minus one plus b times x minus one and plus c times x. Let's see what happens if we plug in the things that make the denominator zero. What numbers would make the denominator zero? What are the bad juju numbers? One. Anything else? Can't be zero because of this one. Those are my bad juju numbers. So those are the numbers I'll test here. Let's test those. Let's see if they worked. If I do x equals 0, the left side is just 2 equals a times 0 minus 1 times 0 minus 1 plus b times 0 minus 1 plus c times 0. This isn't bad. This actually will help because these two both go to 0. 0 and 0. So I have 2 equals a times -1 times -1 is just +1. And I get a equals 2. If it helps, I'll do this. -1 times -1 is +1.
Yeah,
You're looking at me all crazy. What's wrong?
you can get the blue, right? The negative square plus some x plus 2.
Yeah,
So that's cheap.
I plug in x equals 0, x equals 0 here. I sped up the left side. Plugging in 0 on any of these makes those go away. It's not going to do that if I do x equals 1. I've got -2 times 1 squared plus 7 times 1 plus 2 equals A times 0 times 0 plus B times 1 times 0 plus C times 1. The A term goes to 0, the B term has a 0. I'm just left with C. So C equals 7. I'm going to circle those, that way I can find them a little bit easier later on. I multiplied by everything I have, and I still have no B. Didn't get B this way. But we still need B. So what can I do? Well, let's plug in what we got. I got -2x squared plus 7x plus 2 equals A, but A is 2. And C was 7. Now, before I go further, there's a proper way and there's the easy way. Like the proper way would have been multiplying everything out. We should have done it in the get-go. I used the shortcut as much as I could. But if we'd multiplied this out, we would have had 3 equations with 3 unknowns. I'm down to 1 equation with 1 unknown. The only thing I don't know is B. I think it's worth showing the work of writing it out, gathering terms and doing it. Let me pause. People are still writing.
You can go a little bit up.
You're way up there still?
Yeah, I'm getting into the. I'm trying to get in code right now. I have less pages, so I'm trying to do fast.
Yeah, x plus, is that supposed to be x minus 1?
Yes. That's a minus. Good catch. Proper way. The proper way is worth doing because you can see how it works. Because we're going to have to do it on another one later on. Multiply it out. This is 2 times x squared minus 2x plus 1 plus b times x squared minus x plus 7x, which equals 2x squared minus 4x plus 2 plus bx squared minus bx plus 7x. And if I gather my terms by x squared, I have 2 plus b x squared And then I've got,
We're
For
not
my
gonna get any
dad.
break.
yeah, when I finish this problem, I'll take a break. We're
Okay.
almost done. Got one term left. -4 minus b times x. Nope, I got a +7 there too. And then I got a +2. We're almost done. We're going to equate coefficients. And I only need to get b, so I'll only bother doing one of them. I'll set -2 equal to 2 plus b. So if I subtract 2, I get -4 equals b. And I end up with all three terms. We had -2x squared plus 7x plus 2 over x times x minus 1 squared equals a, which was 2 over x, plus b, which is -4 over x minus 1, plus c, which was 7 over x minus 1 squared. That's the final decomposition.
You gonna do the middle part?
What?
You gonna do the middle part, the -4 minus b plus 7?
You can, but you should still get b equals -4. If you do that, you're comparing this one with the 7. -4 minus b plus 7 equals 7. And you get -4 equals b on that one either. Awesome. All right, let's take a 5-minute break.